Hello everybody, welcome to this video. In this video we will see a question based on projection of lines in which one end is in third quadrant and other end is in first quadrant. The question is, a line EF is 90 mm long, has its end E 10 mm below horizontal plane and 20 mm behind vertical plane. The other end is 40 mm above horizontal plane and is in front of vertical plane. Line is inclined 40 degrees to vertical plane. Also, draw the projection of the line and determine its inclination with horizontal plane, apparent length and apparent inclinations. So in this question, given end E is 10 mm below horizontal plane and 20 mm behind vertical plane. So it is in third quadrant because it is below and behind. Now other end is 40 mm above horizontal plane and is in front of vertical plane. So other end is above and in front, so it is in first quadrant. So end E is in third quadrant and end F is in first quadrant. Line length is 90 mm. So just draw a reference line like this, mark a point here, and from there mark 20 mm downwards, 10 mm downwards because it is 10 mm below horizontal plane. So from here mark 10 mm downwards, name that point as E dash, and also from the same point mark 20 mm behind is above. So from this point 20 mm upwards. So in top view, behind is upwards. So from this same point mark 20 mm upwards, name that point as E. Do the dimensions 10 mm and 20 mm. Draw the locus of E dash and E. Now it is given that other end is 40 mm above horizontal plane. So keep some distance from here and mark a point there, and from there mark 40 mm upwards and draw a locus there. So this is the locus of the point F dash. It is also given that other end is 40 mm above horizontal plane and is in front of vertical plane. In front distance is not given, so just leave it. Now from E dash, line length is given as 90 mm. So from E dash, mark a point, cut an arc of 90 mm long here on this 40 mm locus and name that point as F1 dash. From E dash, cut 90 mm and name that point as F1 dash. Similarly, it's given that line is 40 degrees inclined to vertical plane. So from E, vertical plane inclination you can see in top view. So from E, we want to mark 40 degrees. Why it is marked downwards? Because it is given that other end is in front. So in front you cannot mark upwards, you want to mark it downwards. In front in top view is downwards. So from here you mark 90 mm at 40 degrees downwards. Name that point as F2. Draw the locus of F2 and F1 dash. Now from F1 dash, draw a vertical line to the locus of E to get F1. From F1 dash, draw a vertical line to the locus of E and name that point as F1. Now E as center, E F1 as radius, draw an arc like this to the locus of F2 to get F. Connect E and F. Similarly, draw a vertical line from the point F2 to the locus of E dash, vertical line from F2 to the locus of E dash, and name that point as F2 dash. So E F2 dash as radius and E dash as center, draw an arc like this to the locus of F1 dash to get the point F dash. Connect E dash F dash. So this E dash F dash is the front view and EF is the top view. On observation, you can see that E dash and F dash line, this is the distance between end projectors, and these two lines will be parallel. On observation, you can see that this line and this line will be parallel. Now you want to find the apparent length. Apparent length will be the length of the front view, that is E dash F dash, and length of the top view EF. So measure this E dash F dash and EF. Also you want to find all other angles. Alpha is alpha, that is the actual inclination of the line with the horizontal plane, is 34 degrees. F1 dash E, that F1 dash E makes with reference line, that is 34 degrees, and also the apparent inclination of the front view will be the inclination of the line E dash F dash with the reference line. So that is 46 degrees, and also we can get the inclination of the top view, that is EF makes an angle 50 degrees with reference line. Thank you very much for listening to this video. Thank you.